We're finding the domain of functions. Let's do a harder example. Find the domain of k of x equals the square root of 4 over x plus 1 minus 1 over x minus 4. Now, my focus here is going to be to make sure that what's inside the radical is greater than or equal to 0, because we can't have a negative in the radical. So, 4 over x plus 1 minus 1 over x minus 4 has to be greater than or equal to 0. Now, when I'm solving a rational inequality like this, I need to get a common denominator. So, for this first expression, 4 over x plus 1, I need to multiply the top and bottom by x minus 4. And for the second expression, 1 over x minus 4, I need to multiply the top and bottom by x plus 1. So that'll give me the same denominator for both of these guys. Okay, so I have 4x minus 16 over x plus 1, x minus 4, minus, and I've got x plus 1 over x minus 4, x plus 1. I need to distribute this negative sign over both these terms when I combine. So I'll have 4x minus 16 minus x minus 1. And then my denominator will be x plus 1, x minus 4, greater than or equal to 0. So just simplify the numerator, and I'll take this over here. I get 3x minus 17 over x plus 1, x minus 4 is greater than or equal to 0. Okay, now this kind of inequality I can solve using a sign chart. Now a sign chart's just a number line. And on this number line, let's call this giant expression, well, it's basically k of x. So let's call it that. I'll put k of x over here. It's going to be undefined at negative 1 and 4. And it's going to equal 0 at 17 over 3. Now 17 over 3 is almost 6. So I need to put those numbers on the number line. Negative 1 goes first, 4, 17 over 3. It doesn't have to be to scale. And then it's undefined here, so I'll put a u. Undefined at 4, so I'll put a u. And then 17 over 3, the whole thing's going to be 0. So I'll put a 0 here. Now these three numbers divide the number line into 4 regions. And I have to test each of these regions to see whether k of x is positive or negative. So let me do that. Let's test to the left of negative 1 with x equals negative 2. So I'm plugging negative 2 into this, and I get 3 times negative 2, negative 6, minus 17 is minus 23, over negative 2 plus 1 is negative 1, times negative 2 minus 4, negative 5. I don't need to know what this comes out to be. I just need to know whether it's positive or negative. Now the denominator is going to work out to be positive, and the numerator is negative. So this will be negative. And I have negatives to the left of negative 1. Let's try something in between negative 1 and 4. 0. When I plug in 0, I get negative 17 on top. 1 times negative 4 on the bottom. That's a negative over negative, which will be positive. That means it's positive in here. Let's try 5. X equals 5. We get 3 times 5, 15 minus 17, negative 2, over 5 plus 1, 6, times 5 minus 4, 1. A negative over a positive, which is negative. So it's negative between 4 and 17 thirds. Now 17 thirds is very nearly 18 thirds, which is 6. I could plug in 6 to find out what happens to the right of 17 thirds. So I get 3 times 6, 18, minus 17 is 1. 6 plus 1, 7. 6 minus 4, 2. It's all positive, so I have a positive value over here. Now, let's remind ourselves what we were looking for. When is this expression greater than or equal to 0? Well, it's greater than 0 between negative 1 and 4. It's greater than 0 over here. And it equals 0 here, and that's okay too. That's okay for our domain. But we got to stay away from negative 1 and 4 because the rational expressions are undefined there. So this is going to give us our domain, this interval and this interval. Our domain is from -1 to 4 and from 17 over 3 to infinity. Oops. And I need to include 17 over 3 because the function's 0 there. So 17 over 3 to infinity. And that's our answer.
By 2. I can't do this with you two laughing back there.
Work it. Work it.
So if we had, no, that's not right, 3 coplanar points.
So have you ever gotten off an airplane?
That should be less than. Yeah. Dang.
Is it like 500 degrees in here or what?
All right, so when you're in chemistry class, you're going to be doing a lot of work. You're going to be starting over.
So as an example, we could consider like you've got a chain hanging from two fixed.